All right, so the best way to start a new project with UIX is to go to the repo of the project, scroll down, and here you will find an npx command that bootstraps a new UIX project. So if you have already npm installed, you can use npx. It's coming with npm. And if you copy it and go to terminal and run it, this will create a front-end project with UIX, Shadow, CLJS, and basic CSS bundling. If I go to my app, it says run npm run dev here and npm run release for production build. I'm gonna run the dev mode. You can see that it starts CSS bundler and Shadow CLJS in parallel. So it's building now. And once it's done, we'll go to localhost 8080 and we'll see the app running, right? And in the console, in the browser console, you can see that Shadow CLJS is ready and it's gonna hot reload. Depending on what kind of project you want to start, you may want to use different flags in the starter project. So if you're just creating UIX app without any flags, it's going to create Shadow CLJS and UIX project, purely front-end project. If you add reframe flag, this will also create front-end only project, but together with reframe. You can also create React Native project or Expo project for React Native, and you can create full stack project that you can host on Fly.io. So the Fly.io flag is going to create a normal front-end project without reframe, plus a Docker image for Fly.io and a little bit of backend code. Let's take a look at the structure of a front-end project now. So first of all, we have package.json, and when you run the script to create a project, it will also install dependencies for you, so you don't have to do it manually. You can see that we have npm dev script, the one that we just ran, and it starts Shadow CLJS in dev mode and runs styles dev, which in turn runs Lightning CSS CLI. So that's a tool for transpiling and bundling CSS, and it keeps watching the CSS file and it will be bundling all of them into a main CSS file in the public directory. So public directory is the one where all static assets are served from. You can see that we have bundled main CSS here and index.html file where both the CSS bundle and JavaScript bundles are linked, and the app is rendered into the root element. So next, let's take a look at Shadow CLJS config. It's pretty basic. We're just saying here that we're going to use deps.eden for dependencies. Development server for serving static assets is running on 8080 and serving files from the public directory. The build is called app. The target is browser because we're building for browser. The module, we only have one module, which is main, and the entry to this module is app.core. And there is an initial init function, app.core init, which renders the app when the script loads. We also have a couple of preloads for development. First, it's a uix.preload namespace, which includes code needed in development for fast refresh, for hot reloading without losing local state. And also there is a DevTools preload. So this is a tool for pretty printing data structures in browser console. So now if we go to deps, we have closure script here, UX core, UX DOM, Shadow CLJS, and DevTools. Pretty straightforward. So in source directory, first of all, we have the CSS file. The script for styles is gonna watch any CSS file, like all of them, whatever you have in the source directory, so you can actually chunk your CSS and follow the structure of your UI code. For example, if you create like a components namespace and then widgets namespace and then the header namespace, the main, the button, like whatever you do, you can also split CSS in different files and put them next to UI code. And this script is gonna take care of finding all of those files and bundling them into a single bundle, right? But for now, we only have the core CSS here and core.cljs. So this is a really minimal example of, it's not even an app, it's just something, just a header with a text that's rendered by UIX. So you have to obviously require UIX.core to create elements and components, UIX.dom to render stuff. And here we have a tiny component, and then we create a root. So this is a React root. This is like a special thing that tells React, hey, this is the entry point in the DOM where the app will be managed by React. So you have to take a selector, you have to find a DOM node and then pass it to uix.dom create root. And it doesn't really matter, you can do it def, but I prefer to do it with def once so I don't have to recreate the root. And I think in the case of when you are using fast refresh, you have to do it with def once, right? Because fast refresh reloads the app without actually re-rendering it. So it's a little bit smarter than traditional hot reloading. So you have to use def once. And then we have a render function and then the init function, which is exported. We have to export it. So inside of shadow CLJS config, we can actually refer it. And when the script loads, a little bit of runtime code is injected by shadow CLJS, and using this reference, it will execute the function which will call to render function, and the app will be rendered. So in order to render the app, we're using UIX.dom render root function, and we're passing app component and the root, the React root, which refers to the DOM element. Now, one thing to note is that I'm wrapping the app element with a strict mode element. So the strict mode is only running in development, and this is basically a way for React to catch bugs in development and report them to you if you are doing something wrong and unexpected. The strict mode will double check stuff and it will print errors into the console, so you will be warned during development if something is wrong, and it's safe to leave it here like that for production builds. It's just not gonna run there. If you're not familiar with strict mode, you should definitely go to react.dev website and read documentation about the strict mode, how it works, and what should you expect. And that's basically it. If we change the text, hit save, go back to the browser, you can see that it was hot reloaded. It's there. For fast refresh, let me demonstrate you how to maintain local state. For example, we can create a local state that maintains a number. We're going to create a counter. Let's say I will have a button, and we are only going to increment numbers. So on click, I will set num inc, right? And here we will render the number. And of course I cannot just do this, so I need to return something. I want to return both of those elements. Right, save. Okay, so now if I hit the button, we will increase the number. And for example, if I want to decrement now, I will update the code, hit save. And if we go back, you can see that the button updated, but local state is not. So that's what fast refresh is doing. This is actually a package. Oh, sorry, it's called React Refresh. Yeah, this is an npm package, and uix.preload namespace is the one that's using this package to enable React Refresh during development. That's it. There will be more videos on UIX, so stay tuned.